Thank you very much, and thank you for the introduction. And thank you also for the opportunity to speak to you at the FAR conference in Aotearoa, Kia ora. I want to talk to you today about, as the introduction said, about what we are working on. So introduce different kinds of solutions that are already out there or in development in terms of autonomy in the field, but also speak about our combined powers project that we are working on between KRONE and LEMKEN. So I myself, I'm Eva Schröer-Merker, and I work for KRONE Agriculture. So let's start a little bit with an overview about the different kind of solutions that are out there in the market. You see here, I hope you can see my pointer, the Exceed robot. It's a Dutch development that is already out there in the market. And I know there are already some working in Australia. And I think maybe also in New Zealand already, so they are already quite visible on the international platform. What is important to know here is that they focus really on the autonomous traction unit. So they say everything that's behind, like work quality and everything, that needs to be done by the implement manufacturers. Then I just want to give the different kind of the spectrum, which is basically Nexat that is being developed. You see already the first machines out in the market. At the moment, they are not autonomous yet. They are working intensively towards autonomy also. So, and if you just see the size of the gantry here in the corner, you see a human. So just by judging from the scale, you know that this is being developed for really large scale arable farms. On the opposite side of the spectrum are the really small robotics. So this is a development by Fendt, the tractor company, where they said, we want to look at small, scalable robots that you can use as a swarm in the field. By now, they have stepped back a little bit from that goal. They say this is just to develop the general functions of autonomy. But of course, once we get swarm robotics to work precisely in the field, also smaller robotics can be of interest. And then this one is probably the most visible worldwide at the moment. It's FarmDroid, and it's a Dutch company, Danish company, and they have developed this robot that can seed and hoe. It's not very intelligent, so it can only hoe the crops that it seeded itself. It is developed with a solar panel, so it can run on sustainable energy, and they have already sold over 500 of these robots. So they are specialized mainly on high-value field crops such as onions or organic agriculture. And then, of course, I think everybody has heard about the 8R that John Deere has autonomized. So far, from all I know, these are still not yet available in the market. However, all the big tractors of John Deere are already coming pre-equipped with the autonomy stack. That means that once it becomes available in the market, you only need to buy the additional hardware and you can use the tractor also autonomously. Obviously, here you have the advantage of having a standard tractor that you can also use as a normal tractor in the field. Then this is a gantry that has been developed by the company Horsch, an OEM in Germany. They had a couple of autonomous projects going on. They stopped the autonomous traction unit. However, they said we continue to work on the big gantry, and they targeting especially Latin America and Brazil with that, where they say the areas are big enough and also the regulations are favorable to autonomy. There are not as many restrictions as in Europe, for example. And then we have solutions that are, let's say, semi-autonomous. This is a herbicide machine by Eco Robotics. That's a Swiss company. where the machine itself is fully autonomous. It works with artificial intelligence to tell the crop from the weed, and you can save up to 90% of the herbicide. However, you still need the human to drive the tractor. So there's a vast area of development out there. I know also in Oceania there are really good and interesting companies working towards autonomy. So it's a lot of things happening in the market. Some solutions are already available, others still in development. And one of the things that is being developed is combined power. So the companies KRONE and LEMKEN have joined for this specific project, and we want to bring autonomy into the field. So what is the advantage of two OEMs collaborating towards autonomy? For us as implement manufacturers, the advantage is really that we have control over the process that we want to bring into the field. So we can see what is the work quality, what kind of interface do we need between the traction unit and the implement. And having said that, we are not working towards an insular solution. We are at the same time working in the AEF, for example, towards standardization of these new signals that are being sent between the implement and the traction unit. But of course, we have a completely better and different position in working towards the standardization when we know already what kind of interfaces do we need, what kind of signals does the implement need to send towards the traction unit in the future. And this is just a quick overview to explain that once you work in autonomy, there's a lot of different areas that you need to focus on. So for us as OEMs, this is where we're coming from, the implement know-how, and that is what we want to bring into the field, so the process intelligence. For that, we necessarily need also the drivetrain, so the traction unit that goes into the field, because then we can work towards process automation and work towards the interface that we need between the machines. Navigation and environment detection, they are necessary. Without them, it's not working full stop. And communication is a huge part. So it's between the traction unit and the implement, it's towards the cloud, and so that you can send the data into the different farm management systems and use it there, but also to send it towards the operator so that the operator can remotely tell how the machine is working. Now let's focus a little bit on the machine that we are working on itself. So here we have a 230 horsepower diesel electric drive. So the diesel motor basically powers the electric drive and the PTO. From the dimensions and the weight, it's similar as a standard tractor. And you see in the video on the bottom our transport solution, where you basically just tow it behind a normal tractor. And it's designed so that you can hitch it under a mounted front implement. And with that solution, you can drive also, let's say you can drive towards fields where with the standard solution that many robotic companies have nowadays, which is the low loader, you couldn't reach those fields that you can reach with this transport solution. So that was for us a big step forward to simplify the transport of the robotic system towards the field. Now, I mentioned it already briefly before, it's the process intelligence. So the process in the field, what you want to do really needs to drive autonomy, because when you don't have a driver telling the work quality anymore, or if everything is still working, then the implement needs to be able to communicate that and to run the process basically. And it starts already with, do you want to do the headland first, or do you want to work the infield first? How do you want to deal with problems in terms of malfunctions or when something is happening? And that continues throughout the development. So here you see the path planning. On the left-hand side, we have the hoeing, where you follow the seeding tracks. However, this curvature that you see here in the crop, that hasn't been in the seeding plan. So we found a solution there where we used the camera, which is normally used on the hoe to detect the crops, and we put it in front of the traction unit to basically oversteer the automatic path planning. Another thing which is very important for us in Europe and Germany specifically is the wildlife-friendly mowing, so that you do the headland in a U shape and you define a safe space up front. So you basically drive on the headland and then you push the wildlife into the safe space so that it's less risk of the wildlife getting injured. And as you don't have a driver on the tractor anymore, the user interface becomes even more important. So that needs to be done in a very intuitive and easy to handle way. So our aim here is to work towards something that is as intuitive as today a mobile phone. And you need to be able to do the planning of a new task, but also when you see it here in the bottom, to control remotely how's the machine working, where am I at in terms of the task, what time do I need to pick the machine up and can bring it to the next task. So these are all things that we are working on in parallel. And as I said, our goal is really to be interoperable in the future. So of course, for me, it's lovely when the customers want to use our smart implement and our autonomous traction unit. However, we also work towards that our smart implements can run behind other autonomous traction units, and at the same time also work behind a standard tractor, because also that becomes a problem. When you don't have the people anymore to work on the farm or the qualified people to work on the farm, then also the smart implement becomes more important into the future. Now, and with that, I would like to close basically to say that for us, autonomy needs to be driven by the process, and we have the sensors available for that. So that is not the problem anymore. We now need to work on the communication between devices, but also different manufacturers. So we need the standardization and norms so that farmers and contractors can also run their colorful fleets in the future as they are doing today. And for that, we need legal frameworks and regulations that are also practically handleable in order to have implementation and deployment in the field. Thank you very much.
Good, thank you, danke, Eva. Can I just check, can you hear us? Can you hear me, Eva?
I can hear you.
Okay, just because you're not able to join the panel discussion, maybe we will try and answer just one question. If somebody has a question they'd like to put forward for Eva. I've got one ready if no one wants to step in. Eva, just one question for me maybe. On this pathway for automation, is it all going to require new machinery, or what role do you see for retrofitting of existing machinery?
That's an excellent question. Thank you very much. So yes, in the way that we are developing autonomy, we can retrofit standard machinery, and also our robot is working with a standard 3-point linkage. So already now you can, in theory, put any kind of standard implement behind our robot. However, if the implement isn't smart, you won't know when something is broken or clogged up or anything like that. So yes, we are working towards retrofit and using standard machinery.
Thank you very much. That's a very interesting presentation. I'm curious why Lemken and KRONE, as two very large companies that are largely competitors, decided you needed to come together on this project. Can you give us a bit more background on that? Thank you.
Yes, I can. Thank you very much for the question. Thank you for calling us big companies. In comparison to some others, and also in comparison to some tractor companies, we are still relatively small. So that was one of the things. So if you are working on autonomy. As I explained before, you are working on a large area and many different fields that you need to focus on. So that obviously is easier when you can spread it on 2 shoulders. KRONE and LEMKEN are not direct competitors because LEMKEN are more in the arable field and KRONE is more in the forage harvesting field. So that works okay. However, in the beginning, now talking a little bit shop here, our 2 companies, we wanted to basically make our implements smart. That was the first step. So we approached the larger tractor companies and asked them what our implements need to do in the future to be able to control the tractor when nobody is sitting on the tractor anymore. So what do we need? What kind of signals do we need to send to basically adjust speed, adjust working height, and so on? And you can probably all imagine when you ask a big tractor manufacturer what you need to do in order to control their tractor, the response is a little bit reluctant, let's say. So that was basically the starting point when KRONE and LEMKEN said, let's see if we can bring autonomy into the field ourselves.
That was an awesome presentation. Is it going to be a purchase model or a leasing model for these autonomous tractors?
That is not yet fully decided. Thank you for the question. So probably we are going to do both. We are in contact with a lot of farmers that are interested in autonomy, and the larger ones say, okay, I can deal with a higher model at the beginning, but in the end, I want to purchase it also. For us as manufacturers, of course, the hiring model is more attractive in terms of we still own the machinery, we can play updates onto it, and so on. So there is advantage of both things, and we probably will make both available in the future.
I have to ask one more question. I'm sorry, I can't hold myself back. Eva, you mentioned interoperability towards the end there. How far do you think we are from plug and play across mixed fleets?
I can say that at the beginning of last year, the AEF Autonomy Group was started. So AEF is basically the organization working towards standardization of agricultural equipment. So at the beginning of last year, they started the Autonomy Group, which also one of my colleagues is a member of. And so far, they are going quick and well. When it comes to the stage of actually signing and implementing that into a standard, that's still probably a little bit in the future, 1 or 2 years, I would say. However, there is a huge interest of multiple companies, large companies all over the world to work towards standardization. But having said that, we know also from what we have already in the field today that there are still sometimes problems, even with machines where the companies are also in these organizations. So I can't promise you anything, but I can say that we are strongly working towards it.
Thank you, Eva. Vielen Dank. I think we'll need to end there, but thank you again. Maybe one more round of applause for Eva.
Thank you.